Hi everyone, good evening. There is some small correction in the introduction. Actually, I have my CEO here. I'm the CTO of the organization, but it's look fun. If he's allow me as a CEO, I'm happy to. But I know it is not possible. Right. Thanks, guys. So I'm very glad to be here. This is my first event happening in Chennai. Usually we travel to Bangalore to deliver some talks and things, but I'm very happy. I'm from Pondicherry. Uh, we have office in Pondicherry, so usually I travel from Pondicherry to Bangalore to do all these things. It's a very new experience for me also, and happy to connect people. Thanks for the community contributors and organizers, everyone. So today I'm going to share important topic, not much theoretical, not going into hands-on, but I believe I can share something what I do, my organization do in the Patroni setup every day, tuning, optimization to deliver real-time RPO things. In distributed system, 30 seconds is very important. Everyone agree because switching happened in the failover time. The switching happened in the 30 seconds only. Purely, I am from distributed system because I am very good in Mongo and I am very good in Postgres. So I like distributed system very much. Even in Postgres, I always push my customer to go Patroni, go to Patroni, because I believe it is very seamless to switch the primary to replica and standby, synchronous, whatever it is. So Pattern is very good replication stack to deliver to our customer in high availability solution, but we need to have a very fine tuning configuration which well aware about the system. That is what I'm going to share here. One second. We'll keep it. So, as I introduce, I'm Manosh Malai. I'm 15 plus years of experience in database, DevOps, and developing platforms. My DB is also into developing platform. We are developing a micro SaaS solution. Right now, we are supporting customers who have a very big data in the archival, online schema migration in MySQL, everything. We have a robot system. We call this as a Bifrost. So we are actively participating in the micro SaaS solution, and I'm actively speaking in tech bloggings and other things. So what matters today? What this talk is about? So why people choose Patroni? The biggest bottleneck what we see in Postgres, right? When primary crash, the primary crash, someone need to jump in and need to make replica as a primary. So this kind of human intervention is reduced by the stack called Patroni. So another thing is in the Patroni, there are different components we are having in the system. One is called HAProxy, another one is called etcd, Patroni, and Postgres. So in this all this component, everyone having its own key role to achieve the RPO. That is the main goal what we are talking here. So when we are talking about this Patroni, right? People, when they started to implement the solution in the system, they know what is the component, what is the purpose, but they fail to go little one step ahead to understand what the quorum lost, what the leader lock actually expired. The leader lock is a very key role in the Patroni setup, correct? So the leader lock only help to define if the lock is expired, how the entire re-election got happened and the new primary got elected. Everything is a key role in the Patroni. The time of the expire is 30 seconds. 30 seconds, that was the title also. In 30 seconds, what is happening? What are all the parameters involved in the 30 seconds? What happened if there is some misconfiguration happened? This, the team failed to understand, implement in the Patroni setup. This is what the stack I explained. Applications speak to HAProxy. HAProxy speak to Patroni and Postgres, and Patroni will speak to etcd. Basically, Postgres, I'm not going to talk anything about Postgres, no Postgres. So I'm going to talk about only HAProxy, Patroni, and etcd only. Because everyone know about Postgres, this topic is whole about Patroni, HAProxy, and etcd. So that I like to have a key highlight. HAProxy need to trust Patroni, Patroni need to trust DCS, the DCS trust Raft. Because DCS is built on Raft algorithm. I hope everyone has some understanding about Raft. It's a very good distributed system consensus protocol. Coming to the etcd, so I hope anyone aware about MongoDB. By default, MongoDB have Raft implemented inbuilt in the core system. In Postgres, we don't have that kind of solution. That is where to achieve the Raft and consensus distributed system, people introduced etcd inside as a component. So when we are talking about Raft and consensus, distributed consensus, it need to be maintained quorum. The quorum is always need to be 3, odd number. If we have even number, that won't benefit us. We have a good math for it. For example, we have a 3 etcd component in the system. I hope all aware about Patroni. All aware about Patroni. Do I need to give some basic about Patroni? Patroni, okay, fine. So, we have master and replica, and lot of standbys we have. If your application is there, you will tell this is the reader endpoint, this is the replica endpoint. When something goes wrong, you need to tell your application to point, this is the new master, this is the new replica. So this is one problem statement, and another problem statement is, you need to reconfigure the new replica as a primary, and you need to do other housekeeping. So to overcome this, to achieve the seamless failover, to reduce the human intervention, people enable the solution called Patroni. This achieved through 3 components. One is HAProxy. HAProxy help to create a connection string. People may come from RDS background, they have reader endpoint and writer endpoint. Similar, like HAProxy help us to create reader endpoint and writer endpoint. That HAProxy talk with Patroni, which is a application developed by the community, which is enable the REST API. The HAProxy speak with Patroni. The Patroni will understand and speak with Postgres. So your HAProxy nowhere going to talk to Postgres. HAProxy talk with Patroni. Patroni will speak internally with Postgres, and etcd help to achieve the quorum. Because etcd is a distributed system, etcd is a consensus system also. So what I'm trying to say here, so these three system help to achieve this high availability in the Postgres ecosystem. So when we are talking about, I hope everyone aligned now what is Patroni, correct? So if the one primary is dead, one primary is dead, automatically new primary got elected. You don't need your DBA or no one need to go and do anything. So everything is automated, and your application, once you define this is the reader endpoint, this is the writer endpoint, this is the reader endpoint port and writer endpoint port, that's it. You can create new replica under that. You don't need to bother about anything. So your system no need to bother about, your application no need to bother about which is the primary now, update the connection string, update the reader string. You don't need to bother those things. So particularly this quorum, right? So when we are talking about etcd, I think there is some problem. etcd, right? etcd, we need to keep always odd number of process. Even you are keeping in one single machine, different machine, or you are creating 3 Patroni Postgres machine and you are keeping etcd none bothered, but you need to have odd number of system so that the quorum and the election will be happen. You proceed. You proceed. So if your etcd die, your entire Patroni is die. Even your Patroni Postgres is up. You have a 3 Patroni node. You have a 3 etcd node. 3 etcd is down, but primary replica, everything is alive. But HAProxy can't accept the connection and give it to the read replica. But there is some shortcut and there is some config we can achieve. That is I'm going to say. But basically people don't enable that. But there is option. If this is the architecture, we have a problem. You have your laptop?
Yeah, can I?
Yeah, please, please. Sorry, guys. Okay, we don't need to bother about it. I will take this. So, Manosh, you talk about what is Patroni. You talk about what is etcd. Let's come to the next. How primary got elected, how this system is going to work. Basically, in all this distributed system, we have one primary, another or slave. Because the slave will follow primary. When that king is died, new king need to be elected. So when the old king is there, right? I am the king. So I have a token called reader lock. That is a token which is in everyone know etcd is a key system, key and value pass system. So there will be entry in the etcd. This is my name Manosh and my token expiring 32nd. This entry will be inside the etcd. For example, Karthik is my replica. I have another replica called Ponsuresh. So this guys is my replicas. Every 10 seconds we called a parameter called loop. They will go to etcd and check Manosh is alive, Manosh token is expired or not. Every 10 seconds. Manosh token is not expired. Okay, Manosh is alive, he is the leader, let's follow it. So if I am also a one member of that, right? I need to check. So what I do, my Patroni process first will check internally my Postgres is alive. Because this is not a core system. This is not the Postgres community is not built anything inside the Postgres. Everything is a different component and interconnected. So this Patroni process is an external process. It's run inside together PostgreSQL machine. That Patroni process will check Postgres is alive or not is the first thing it will do whenever the loop time is come. The loop time is 10 seconds. Every 10 seconds, that individual Patroni process, either it is primary or replica, it won't bother. It go to its own Postgres, it's validate, this process is alive or not. If this is alive, then it go to etcd and validate whoever it is a primary. Okay, this guy is, if I am Manosh is the primary now, it will renew my key. In the etcd, it will renew my key. So, even though the TTL time is 30 seconds, every 10 seconds I will go and renew my key. Every 10 seconds I will go and renew my key. So I will be a king for good amount of time until I have some problem. Thank you. So this is what the story what I told. So check the local state, read the DCS view, act on the role. If it is I am a leader, I will renew my key. If I am the replica, I will check my leader is alive. I'll go back and continue for another 10 seconds. Again 10 seconds, again 10 seconds, again 10 seconds. This is how the leader lock validation will work in the Patroni system. These are all the important parameters we need to understand whatever I told. The T-tail is 30 seconds. My leader lock time is 30 seconds. Loop wait is 10 seconds. Retry timeout is one important thing. So if you guys are from application background, every application need timeout. That is that. We don't need to complicate. Because Patroni is trying to connect with Postgres. I cannot wait for a long time to replay Postgres. That need to be timeout, right? It is 10 seconds. I also, that Patroni need to connect with etcd, right? It needs some timeout. That is that. So very simple. Patroni is application. I'm talking whatever the parameter I'm talking, this is all about Patroni parameters. Maximum lag failover, if lag is more than 1 MB, the failover will happen. The primary start window is very interesting point. I don't like to share this here. In upcoming slide, I will do it. HAProxy, it's a legacy system, I know, but it's a good system. So HAProxy don't talk to Postgres. HAProxy don't know Postgres. HAProxy only know HTTP protocol. I hope everyone agree with me. So HAProxy speak with Patroni, and the beautiful part I like to understand everyone, it only understand the 200 replay. Because Patroni will replay a lot of JSON output. But HAProxy don't parse that value and come to a conclusion. HAProxy, if I get 200, okay, my master is alive. There is, in HAProxy, some people will come from the DevOps background also. If you see some config, what I'm trying to say. There is, you have a website, if slash is coming, you will go for a virtual host. In the virtual host, you have a multiple entry for 1, 2, 3. In that, we will tell if the primary is up, this is the thing you need to do. So that side of config, I'm saying slash primary, slash replica lag equal to 1 MB, slash read only, slash. So this endpoints go and touch the Patroni endpoint. As I told, Patroni is the REST API endpoint. Go and touch, it will return some JSON value, but HAProxy don't understand anything. HAProxy will check the output it's giving by the Patroni is 200 or not. This is very key important because a lot of database engineer believes HAProxy is parsing the output which is given by the Patroni. HAProxy, no. But we can achieve that. In HAProxy, you can do some header parsing and everything, but it is so extensive job. None of the team people is doing that, but we can achieve it. This one important thing, that's what I put highlight there. HAProxy does not check Postgres directly. It checked the REST API on 8008. So the 30-second window, I like to share some interesting. If you see, we will take a TSO 0.0, my primary die. And that time, the leader key in etcd is alive only. HAProxy, we have a config in HAProxy. If you saw the top, that side. HAProxy intern 3 seconds, fail equal to 3, rise equal to 1. HAProxy try for 3 times. If I'm getting error, I mean non 200, it will mark that endpoint as a dead endpoint. It won't allow any application to accept, but inside the Patroni, etcd, everything, I am the king. But for Patroni, so for HAProxy, I am die. So the connection gets stopped failing there. This happened between 0 to 9 seconds. Why? Because what is the loop time? 10 second, right? And the TTL expire time is 30 second. So I also told when the loop time is started, the Patroni will go and check my Postgres is up or not. That parameter is primary start timeout. Here it is 300 seconds, but I will tell why it is 30 seconds. So 30 seconds, after 30 second expire, my etcd leader key in the my Patroni leader key in the etcd will mark as a dead because my Patroni process didn't go and renew the key because I'm died. After that, some process will happen. By 41 second only, your new primary got elected. It's look like 30 seconds, it take 40 seconds. If you have a very good config, what I'm going to share. If you are going to use default config, it takes 5 minutes, 5 to 6 minutes. So this is what I try to share with you. When sometimes it's go to 15 minutes also. So primary start timeout is default is 300 seconds. It's been 5 minutes. As I told, right, Patroni first loop time, what it will do, it will go and check whether the Postgres is up or not. 300 seconds, it will wait and retry every 10 seconds. It don't inform etcd, my Patroni, my Postgres is died. So if I said primary start timeout is 300 seconds, which is the default parameter, 5 minutes, my Patroni don't tell to my etcd, this guy is die. And another beauty is, it's always renew in every 10 second of loop. So in your production, the recommended value for primary start timeout is 30 second to 60 second. But default is 300 second. This is what I shared. So if your default value is 300 second, your outage time is 5 minutes plus the 60 second what we saw. This is the math. If you see the HAProxy, right, because we have retry interval, fail safe, everything, those things will come into the picture, so it will go to that time. So what is the recommended value from my end? If you are too tight but safe, your system is very too tight and safe, you can go for 30 seconds. Otherwise, there will be lot of primaries which happen for small things. More comfortable marginal value is 60 seconds to set in the production, what we usually follow as the best practices. Synchronous mode is very interesting feature in Patroni. All Postgres guys know we have a replication synchronous and asynchronous. This is one of the things. In Postgres, when you are setting synchronous mode on, it's very important. Yeah, I will get whenever I'm doing. So first I will give some basic understanding what is synchronous mode. So whenever I'm doing synchronous mode on, I can tell sync one replica as a sync node, sync standby. So whenever some writes are happening in primary, that sync standby node also need to acknowledge my write. That is the sync standby node. Whenever I am on synchronous mode on, the behavior is very aggressive. There is another parameter we called synchronous hang sticked. That is one. So it is so aggressive. In this case, I have a PG1 as a leader. PG2 as a sync standby node. I enabled sync mode on, so my leader and sync standby died. I have one replica. P3 I have it, but I cannot do my business. It's look like the write won't be accepted by the HAProxy. Why? Because we committed my sync node need to acknowledge my write operation. P2 is my sync standby. It need to acknowledge my write operation. Even one person alive, I don't bother. This is my game. So knowingly, unknowingly, DBAs or the DevOps, whenever they're setting up, understanding the business critical and right intention, so they said standby, but something goes wrong. This is the situation. So the only option, we need to go to the Patroni and we need to run this command to make PG3 as a primary, otherwise your entire operation will fail. No write operation will be accepted by the cluster. So what is the alternative option? You can do sync node count, you can set to. So even other node, if PG3 is available, that node will accept the write and start continuing the business. What I'm trying to say, if it is Mongo, right, it is not achievable. Some people saw from Mongo. Even one node is there, the primary is not there. Again, you guys go and make that node as a primary because there is no voting member in the system. The same scenario, but it is different, right? The components are, we have separate etcd, HAProxy and Patroni, right? So here we don't have that flexibility to awareness. So here, whenever you are setting like the synchronous mode strict on and synchronous mode on and synchronous node count 1, the situation is quite worse. Even one node is there, it is able to serve the business traffic, your write operation will be get blocked. This is another interesting feature. Do you see as unreachable? Sorry. This is unreachable plus fail-safe mode off. So as I told in the initial of this talk, I have Patroni, Postgres and etcd. Very unfortunately, the etcd node down, but all my Patroni and etcd, so Patroni and Postgres is up. It is not. The system won't accept the read and write. HAProxy won't allow any read and write operation when fail-safe mode equal to off. Why? Because I don't have etcd, I don't believe you guys. I don't know who is primary and everything. But in certain cases, certain situation, etcd go down and come back very quickly, but that 5 minutes or 10 minutes, my business will be down. So, but since my Patroni setup is alive, I have one feature called fail-safe mode on, right? What it will do, it talk internally with other Patroni member, are you guys available? For example, here myself, Karthik and Ponsuresh is there. Karthik is primary, I am replica, Ponsuresh is the replica. My etcd went down. When because every loop time I will check the etcd, right? I came to know my etcd is down. That time, I don't need to wait for my etcd. I internally speak with Karthik. Karthik will speak with me and Ponsuresh will speak with me. We understand, okay, we are up. I believe etcd is down. Okay, we don't need to stop the business, we continue it. So this is one important feature you can enable. If you feel even the etcd is down, I can run my show. This is highly recommended parameter we follow in the system. So this is what the story. So the 10-second hiccup will create a lot of chaos. So as I told, so whenever you are doing right, this is the config what we put in HAProxy. HATTP check expect status is 200. It won't understand your JSON what Patroni is replying. It only understand the written code of the Patroni and do the business process. So, but but you can do HTTP check string, and you can do HTTP check expect R status. Who know this one? We can do some regular expression homework in the HAProxy config, and we can parse the JSON value, and we can achieve the result more accurate. But this is not a standard practice we are following. This is how the system works, but you can achieve it. So these are all the HTTP endpoints you can use in your system. For example, you need to point your read to sync node only. For example, we have a sync node, sync standby node. In the endpoint, you can tell slash sync on, and you can tell I don't need any read replay from more than 1 MB of lag. I can tell slash replica question mark lag equal to endpoint. So it will go to that endpoint and fetch the read queries, not in the other one. This type of status code you can use in the HTTP and get the result. So now we came across a lot of things. So what is the parameter we need to fine tune and get the result? But what need to be achieved when something goes wrong in your Patroni, etcd, HAProxy? First, I highly recommend to read your logs, because reading log is very important in troubleshooting. Don't ignore it. So you need to read your new primary log. You need to read your old primary log to understand what is the cause of the switching. And you need to understand what happened during my 30 second. You need to understand the etcd log. You need to understand the HAProxy log. I have shared some pattern for you guys. I'll also publish this slide in the forum what they are doing. This are all the way key string. We will do it in our real time. We have a separate system, but initial consulting those places we use is to understand important things. I know it is not much visible, but I will share the slide with you guys. You can get it. Whenever pre-failover checklist, you can use this command to see what is happening. And this is the Patroni config reference what we use in our work, not from the default one. We use this one. I recommend to go a look, and you can use up to your standard what your organization load is. There are two different systems we have: control plane and data plane. So understand your control plane, understand your data plane, put your monitoring efficiently when you are using Patroni. You will get a lot of important metrics to fine tune and get the outcome of this one. Final takeaway, what the purpose of this talk, the parameters you need to fine tune effectively and keep the system to achieve the appropriate RTO. So I hope this config will help you guys. Don't go with the default config, and don't enable synchronous mode on unnecessarily. So you need to have some purpose, and you need to have a proper run book internally if something goes wrong, because every engineer who is in on-call don't know synchronous mode is on, and they suddenly get into the problem and they troubleshoot in some other way. Finally, you guys come in. So make sure your system is server. Thank you. Thanks all.
Let's now open the dash for any questions if there are any from the audience now to Mr. Manosh.
Yeah, I've got a question. I come from the networking domain, so this might.
Hi, sir. Hi, sir.
So you've heard of VRRP, right? Virtual Router Redundancy Protocol?
Come again, sir?
ERP.
ERP.
VRRP. These are some of the standard protocols that they use in networking.
Okay.
For failover, if in case the primary goes down and the secondary has to take over. Now, why can't I have just a simple virtual IP address for all the Postgres active as well as the replicas, and redirect the queries from HAProxy to that virtual IP address, the primary alone will have control over the virtual IP address initially. When it goes down, you have a mechanism, heartbeat mechanism, using which the secondary realizes that the primary has gone down. And the primary basically grabs onto the virtual IP address. And this switch will take care of the transactions coming in from the HAProxy to go to the new primary rather than to the old one. Why is there so much of complexity being done here with regard to failover when a simple mechanism like a BRRP like failover can be done?
I believe whatever you are saying is implemented here also. I, I understand, maybe I conveyed in complex way, I think, but in the PostgreSQL ecosystem and other ecosystem, the similar way it is implemented. So let me go little different way. You told some protocol. Sorry, sir, I'm not able to recall. Can you please?
Yeah, it's the virtual router redundancy protocol. There used to be a
Virtual
protocol called
router redundancy
hot.
protocol.
Yeah, so
it's
suppose there are two gateways for a network, for a local LAN. One of them is forwarding by default. The other is in the same virtual IP group. And if the primary goes down, the detection happens within 3 seconds, and the secondary takes over with the same virtual IP address.
So virtual routing protocol, whatever you say, that system is Patroni here.
Why do I need a separate node like Patroni when I can configure?
Because you see, you have a router, you have a two router. If one router goes wrong, one router is not up or one router is not healthy, whatever the connection which has come from another router or another switch, it need to route by some other system, right? That is what we called as a virtual routing protocol, correct?
Correct.
Yeah,
They're on
that
the same
system,
line.
anyway, we have one component or a system, here it is called as a Patroni. That Patroni handled by HAProxy. The similar system, what you are saying, is implemented here. So the same load balancer, the same high availability achieved by the system, but I'm not sure where the complexity here. It's a layer 4.
No, why can't you have a simple heartbeat mechanism between the primary and the secondary? And basically check the health of the primary and the secondary simultaneously, both at the primary as well as at the secondary. And if one of them is going down, the other takes over because the virtual IP binding is, there's a switch kind of of the virtual IP binding. And then seamlessly within 3 seconds, you can have the HAProxy forward the traffic towards the secondary. That's the question. Why do we need etcd? Why do we need Patroni to do this? Why do we need HAProxy? Too many components, right?
I understand. I
And
understand.
you yourself said, if etcd goes down, all hell breaks loose, right? So I have another component that I've made part of the system called etcd, and I have to do a health check for it too.
This protocol, right? Whatever the protocol you explained, the virtual routing protocol which create the load balancer, where it implemented? I mean that which system?
At layer 3, it gets implemented. At network level, it gets implemented. But the same can be taken up for the layer 4 and above as well. So you can also have application level heartbeat mechanism that mimics the same VRRP-like scenario.
So since I'm not sure about how the system what you stated implemented, I cannot compare and tell.
Okay. That's fine.
Sorry for it, but this.
Just to answer your question, Balaji, on the networking layer, we are stateless. The data is stateless. Here, the Postgres master is in a read-write mode, and the standby is always a read-only mode. Now, somebody has to make this as a read-write mode. The standby has to become read-write mode in an atomic way that the master is brought down and the standby is taken up. That's what is handled by the Patroni part of it. The Patroni handles that part of it, promoting the standby to master, getting this down. So that's where.
So
It's a health check that's configurable. That's the health check that's configurable. On the node, or maybe over, I mean, it can be a separate VM or it can be on the node, basically. Right.
Just to make it simpler for Balaji, the point is that what he said is implemented at router level. So that connection issue is only detected at the router or let us say at the network level, network infrastructure level. Whether while this problem is discussed is at an application level where the connection going or down is detected only at the application layer. But what he said is that can you have, so it is a kind of a food for thought, can you have a mechanism where all this can be implemented at a higher level so that we can detect this one. That's the point he is saying. So this is food for thought.
That
So this is
definitely a large window
redundancy protocol
basically we need to address.
which is outer level.
I understand. It's a layer 4 level.
Not layer 4, it is layer 3 only.
Layer 4.
IP level. Oh, correct. That is what I'm saying.
Mimic what's happening at level 3 at level layer 7.
4 is saying to mimic it. It's an network
I'm
infrastructure.
just saying, you can just mimic it at the layer 7. You'll get the same failover of 3 seconds, even shorter than 3 seconds. Right now, PRRP used to work at 3 seconds. Now it's got BFD, bidirectional forwarding detection, running between it, the primary and the secondary. It can be done in a matter of milliseconds.
I understand, sir.
You
So it's
have to-
well
you-
thought process.
Yeah, because this is very costly.
Yeah,
30
I
seconds.
understand.
30 seconds is too much.
As a community, we need to
Intolerable.
take this one.
Yeah, we have faced such problems on Postgres. We are not happy with it, right? So, let's some other domain ideas from the networking area. If we are able to adopt at the layer 7 level, we'll be much better off than we are today.
Acknowledge, sir.
So one other thing on the same lines actually, I mean, not from the network layer level,
Oh, sure.
but the question is for Patroni to detect the case that is happening at a network, that the way of detection that the process has terminated is not alive. How is this happening? It's because the both seem not co-located, correct?
It's co-located, or you can separate it's a network level.
Because if it is co-located, I don't really have to go through a network heartbeat to find out whether that fellow has died.
RTP, right? There's one whole RTP you're going on the network.
Correct.
Patroni on a standalone system.
So it's
If I simply
basically-
check by PID that this
No,
my fellow
it's not
PID,
by the PID. It will go inside. Yeah,
Yes, that's what
I
I'm
agree. I
was
agree.
saying.
Yes.
if it happens one shot, then you don't have to try 3 times and hence 30 seconds of an extra.
Align
Okay, so we are not experts in
No.
that area.
You are true, really. You are true. But the thing is, this system, maybe we can request for RFC or recommendation. Maybe it's a good community. Sure, these things will be taken up. It's a really different question forum. Thanks.
Offline as well. Yeah, sure.
Thank you. Split brain. Yeah, it's good. Can we keep it separate?
Yeah, sure.
Thanks.
Thank you, Mr. Manosh. I would now like to welcome our respectable CEO, Mr. M.J. Shankar Raman, to the dais to give the momentum to the speaker.